Hi folks, so today we're going to be talking about some basics of yield monitor data, focusing on how the data are collected and then how they can be used to make yield maps. Yield maps are a visual representation of crop yield within a field. And in this example, the darker green shows higher yield areas of the field, and the lighter green is a lower yield area. Yield maps help us see relative yield differences between portions of the field. So from this map, we know there's a high yield area in the center of the field, and that southwest corner has slightly lower yield. Some folks also use yield maps to get accurate estimates of their average yield within a field or across a farm. In general, yield monitors are going to be better at picking up relative differences in yield, and it takes additional steps to make sure that your average yield estimate is accurate. So how do we make yield maps? Yield maps are typically made using a yield monitor, which is inside of a combine. This is a schematic of a combine with a corn head, but regardless of the grain crop you're harvesting, the mechanisms are very similar. The plant material is going to be cut near the ground level and moved into the combine, where the grain will be separated from the rest of the plant material. And as that separation is happening, the combine continues to drive through the field. The beans get moved from the threshing components of the combine into a holding tank via the clean grain elevator. The yield monitor sits near the top of the clean grain elevator, and most yield monitors operate by sensing the force of the grain as it hits an impact sensor. Note that different brands of yield monitors and combines are going to have a slightly different configuration, but most operate very similarly. The force of the beans as they hit that impact sensor is what the yield monitor is actually measuring. The impact sensor takes measurements every 1 to 2 seconds as the combine drives through the field. This means that individual points on the yield map tend to be very close together in the direction of combine travel, and then they're spaced out into rows or passes, and that distance between passes is going to be set by the header width of your combine. In order to get a single point on this map, the yield monitor and the software associated with it need a few pieces of information. The first is the force of the soybean grain as it hits the impact sensor in the combine. We also need to know the location of the combine at the time that the impact sensor reading was taken, in combination with the length of time that it's taking plant material to move from the cutter bar at the front of the combine through the threshing machinery and then up the clean grain elevator. This length of time that it takes to separate grain from the rest of the plant material is used to set the flow delay, which helps adjust the location data from the combine so that the observation on the map is located where the plants were grown, not at the location where the combine was physically at when the impact sensor reading was taken. So again, the length of time it's taking plant material to flow through the combine in combination with the location of the combine is used to make sure that yield monitor observations are located at the correct spot on your yield map. And finally, the monitor needs to know the width of the combine pass in order to convert the impact sensor reading into a yield estimate in bushels per acre. Yield monitors are excellent at determining where yields are highest and lowest within a field, and that information can be really useful for things like making your scouting plan or delineating management zones. Yield monitors, when they're well calibrated, can also be used to estimate average field or farm yield. And that is very helpful for things like estimating your revenue or for nutrient management planning. But you do need some additional information and more careful calibration if that accurate yield estimate is important for you and your operation. There are a couple combine operation best practices that can help improve your yield map quality. First, you do want to make sure that you're calibrating your yield monitor using the manufacturer's recommendations. You also want to keep your ground speed during harvest within the range of speeds you use during calibration. And then finally, make sure that you're running a consistent header width the whole time. When you use less than your full header width during harvest and your passes are more narrow than is set in your combine yield monitor, you can reduce the accuracy of your average yield estimate. Just reducing your header width by 4 inches on a 30-foot combine head can change your yield estimate by 1 to 2%. Thank you for watching this video. We hope that it helps set you up for a successful soybean harvest. And if you're interested in learning more, you can see our fact sheets on the Science for Success website.